Let's talk about water on Mars. We've known that water exists on Mars for many decades. We see it in the polar caps, and we experienced it up close and personal with the Phoenix Mars lander in 2008. Here you can see the lander legs and the permafrost ice that was exposed by the lander jets. Water also exists as water vapor, and it can exist as part of the structure of minerals. A form of water that we're not used to thinking about. Water we're used to seeing as water, liquid, or as ice. But if you take away one of the hydrogens from water, you end up with a hydroxyl radical, one oxygen and one hydrogen. And both of these can become incorporated into crystalline structures. What happens is in a clay mineral, for instance, you have a layer of silicate mineral here, and then the water can find a place within the layers, between the layers in the structure. Hydroxyl forms here where it attaches to one of the oxygens that has some extra charge, passivates it, and then you have the hydroxyl groups in the structure as well. This is quite common in the solar system, and it's the way that water exists in a lot of places that would otherwise be inhospitable to water as we know it. For instance, the asteroid Bennu. OSIRIS-REx just arrived at Bennu last week, and it's already detected the presence of clay minerals in that asteroid. Well, so what does that mean? What does it mean for there to be water in the crystalline structure? It means that at some point in the past, this asteroid and parts of it were part of a larger body, a body that had formed from particulates in the early solar system, heated up, differentiated, and the water within, like hot hydrothermal fluids, was able to react with the crystalline structure and produce silicate minerals of the sort that we see. And then violent collisions, still in the early days of the solar system, broke that up, and they reassembled into the agglomeration that we see as asteroid Bennu. So the discovery of water in Bennu is not surprising, but it is very important.